What is going on, everyone? Mr. Murray coming to you here with a video on how to write explicit rules for arithmetic sequences, no tricks allowed. So I know that in class writing explicit rules has been really tricky. We looked at a couple of examples, and so I thought I'd make a video just kind of breaking down the process behind how we write explicit rules here, giving you some examples step by step. My hope is that this could be a video that you watch, and if you need to go back and kind of get your bearings, you can do this as well. Okay, so remember that an explicit rule is a rule that tells you the term value, f of n, or depending on if you use subscript notation, you could also use the subscript notation, so you could use a of n if you know the term number, which is n. So for example, if I want to know term 10, I plug in 10 for n, and I get the 10th term in the sequence. If I plug in 100, I get the 100th term. If I plug in 53, I get the 53rd term, and so on. Okay, and so the explicit rule, and again, this is what we call function notation, the f for function, and this is what we call subscript notation. Okay, because we see the n is down there as a little subscript. Okay, so two different ways to write an explicit rule, two different kind of notations. People tend to use them interchangeably, and you could really see either one be used. And so that's why I'm showing you both of them, so you can see both of them be used. All right. So again, in this video, we'll take a look at some examples, and here's the first example right here. So we have -9, -14, -19, -24, -29. Okay, so this is, if we look at the n values, 1, 2, 3, 4, 5, and so on. So in my rule, when I plug in 1, I need to get -9, 2, I need to get -14, 3, I need to get -19, 4, I need to get -24, and 5, I need to get -29. So the first thing I'm going to do is I'm going to look at what we call the common difference. So every arithmetic sequence always goes up or down by the same number. Here, as I go from left to right, we can see that I'm going down by 5. I'm subtracting 5. Okay, -5, -5, -5. If you're stuck, you can look at really any two terms you want. So for example, if I knew that I was going down by 5 from -24 to -29, because you're always going down by the same amount, I could assume that's the case for any two terms. So where that takes me is, so far I know that I have f of n equals -5n. But what about the number off to the side, like the plus b, so to speak? So to figure that out, let's start by plugging in f of 1. If I plug in 1, I'm supposed to get -9. But right now, I get -5. So I have to ask myself, what do I need to put here to get to -9? And the answer is, this needs to be -4. So that -5 minus 4 equals -9. So my rule needs to be -5n minus 4. Okay, that's basically the idea. So you start with the common difference. This is the common difference. And the other number is whatever it needs to be, so that if you plug in, for example, 1, you're going to get -9. Now, I didn't have to choose 1. 1 is just tends to be like a more straightforward number to plug in. I could have chosen 2 as well, and we're actually going to use 2 to check the rule. So if I plug in 2 for n, what I should get is 14, because the second term is 14. Do I get that? Well, -5 times 2 is -10. Take away 4, and I get -14. Okay, the other way you can write it is a sub n equals -5n minus 4. These are both equivalent to each other. So if you do need to go back, feel free and do so. Rewind and take a look at the problem at a slower pace, at your own pace. And then we'll go ahead and move on in a couple seconds. All right, here's another sequence here. So now we go to examine what is going on this one. So I don't really like working from negatives to positives, so I'm going to start here. And I noticed to get from 11 to 30, I'm going up by 19. Is that the same here? Sure. So that just goes to show you that you can use any two terms you want. You don't necessarily have to use the first and the second term, because what you're going up or down by is always exactly the same. So that lets me do f of n equals 19n. And then again, I need to know there's some number off to the side. So what I'm going to do is I'm going to remember that I have these n values here. And again, it does not matter what number you plug in, but I'm going to plug in 2. So when I plug in 2, what I get is 19 times 2. And the thing is, I get 38. But what I need to get is 11. So I could ask myself, 38 plus what will give me 11? Because that's what f of 2 is equal to. So I could try to solve, right? I could get 38 alone, or get b alone rather, by taking away 38. What I get is minus 27. So that means that the number I've got to put in here is minus 27. Okay, and you could write it with subscript notation as well. Again, that part of the notation does not matter. But what does matter is being able to find, right, the difference and that extra number that's off to the side. Remember, I'm not really teaching any tricks here. Just doing some straightforward plugging in. Some people do like to write it like this. Some people notice that it's kind of offset a little bit. So what they do is they write 19 times n minus 1 minus 8. And it turns out if you write it like this, you get the exact same sequence, or the exact same rule if you simplify it. And you might notice that 1, the first term, it goes with like this n value of 1, and this negative 8 goes with the fact that the first term is equal to negative 8. So another way to write it, you don't have to write it like this. Again, if this was like, you could even have written negative 27 plus 19n. There's many ways to write an explicit rule correctly. All you have to do, if I ever ask you to write one on like a pencil and paper thing, as I said in class, is just write an explicit rule that's correct, because there's many different ways to write a correct answer. All right, so if needed, please go ahead, rewind and review, and then in a couple seconds we'll move on to another example. All right, here's another example right here. So again, as we go, I'm going to start going a little bit faster. Okay, so we're going to go ahead and digest what's going on here. Here I'm going down by 14. So I'm going to say f of n equals negative 14n, and I've got to get my other value, my b, so to speak. So I plug in 1, and I get negative 14 times 1, which is negative 14, but it needs to be equal to 26. So I'm going to ask myself, negative 14 plus what number will get me to 26? And I solve, and I figure out that it's 30. So I need to add 30 here, and this 30 will make sure that when I plug in 1, I get 26. And it also works with 2. Negative 14 times 2 is negative 28. When you add 30, you get 12. Okay, and so on and so on. I'm sorry, not 30. 40. 40. There you go. All right, folks. On to the next one. Before I do that, though, I will write the subscript notation. All right. So the next one, we're going to do something similar. Here you can see you're going down by 2, minus 2, minus 2, minus 2. So I set up my rule, minus 2n. Again, I know I'm going to start by figuring out 1. So right now when I plug in 1, what I get is negative 2. But wait a minute, I want negative 7. So I ask myself, negative 2 plus what will get me to negative 7? So I add 2 on each side, and I get negative 5. So I put on my negative 5. I write it in subscript notation. Again, you only have to write it one way. All right, on to my next example. This one's getting a little bit more difficult. I'm going to go term to term as usual on this one. Okay, and I'm going to figure out what's going on as I go term to term. All right, so 23 to negative 62. This one's pretty tricky. So I'm going to go 23, 33, 43, 53. I believe I'm going down by 39. And I can check that because I go 62, 72, 82, 92. Yep, going down by 39. So this one's a tricky one. Though if you're going down, you need a negative number. So negative 39n. I plug in 1, and I get negative 39 times 1, which is negative 39. But wait a minute, it needs to be negative 23. So I ask myself, negative 39 plus what will get me to that negative 23 that I'm looking for? So I add 39 on both sides. Okay, and 39, let's see, 23 I believe is 16. All right, let's see if I'm right. So I'll plug in 3. If I plug in 3, I should get 101. So negative 39 times 3 plus 16. So 39 times 3, so 9 times 3 is 27. Carry the 2, 3, 9, 117 plus 16 is negative 101. Perfect. And so if I was asked to do this in subscript notation, I would write it like this. Okay, so you can see that the sequences do get harder, but the process, folks, is basically the same. You're using the common difference as your quote-unquote slope, and then you're just using some reasoning to figure out your other number right there. So again, you're choosing a number, you're plugging it in, you're getting a kind of like a base answer based on your slope, and then you're trying to use logic to figure out how to find that extra number off to the side. And this is just like if you ever remember solving for the y-intercept when you're writing in slope-intercept form. It's a very similar idea. All right, here's one last one right here, folks. So I'm going to go ahead, I'm going to find that common difference. So here I know that if I'm subtracting 17, okay, you just got to look at the numbers. Oh, actually, a little bit more than that. Subtracting 27. There we go. That makes a little bit more sense. How do I know? Actually, I looked at negative 99 and negative 126. I noticed if I went to this here is kind of how I saw the 27 or 72 to 99. It's a little bit more straightforward. And again, it doesn't matter. All you have to do is look at two terms, one right after the other, and that's how you figure that out. So f of n equals negative 27n. Okay, so what I'm going to do is, again, I'm going to plug in term number 1. So right now, I get negative 27 times 1. So right now, I'm at negative 27. But I know the first term is supposed to be 18. So I ask, what do I need to add to negative 27 to get to 18? So I solve, and I get 9. So therefore, what I'm going to put on here is 9. I'm going to check this. I'm going to plug in term 3, and again, 3 is just a choice, but I need to get 99. 99 is term, not 99. 72 is going to be term 3. So f of 3 equals negative 27. Oh. Negative 27 times 3 plus 9. And that is negative 81 plus 9, which is negative 72. So that checks out. So we could also write it in subscript notation like this. Okay. So folks, again, I hope you found this to be helpful. The idea behind this video was just to provide you with a bunch of examples illustrating how to write explicit rules for arithmetic sequences. Remember, we know that an explicit rule will always tell us the term value when I tell you the term's order or number in the sequence. We have our function and subscript notations. And again, this common pattern of identifying the difference and then plugging in a number and seeing, do I get, if I plug in 1, do I get exactly that first term, or do we need to add something else in there or subtract something else to actually get to that value? So here, when I plug in 1, I don't get negative 9 right away. I only get negative 5. So I need to subtract that extra 4 to make sure I get negative 9. So it's a little bit of pattern hunting. It's a bit of logical reasoning. But what we got to do, we just got to stay positive. We got to stick with it. We got to have confidence. And we got to remember that we can do this stuff. All right, folks? So best of luck. Keep the questions coming. Stay positive. And I'll see you next time.